All right, what's up, party people? My name is Sunny Ray. This is the Sunny Ray Show. What a week it's been! It's been crazy. I have four awesome interviews today, so I'm really excited. We're gonna finish the week off strong. My first guest today, his name is Peter Brady. He is building a company called Certo Systems. It's quite interesting. They're working on a bunch of different things, but the idea is essentially like deceptively simple and quietly radical. They codify the behavior of a piece of hardware into an interactable, distributable emulation. So software teams can build and integrate against it before the firmware is written and before the hardware exists. So, in my words, they're trying to do to hardware what I guess the way we approach software. Well, let's bring him on. We can get him to help us figure all this stuff out. So, Peter, what's going on, man?
Not much. I'm excited to be here. Thank you.
Yeah, I'm excited to have you here. So, Peter, tell me what are you building at Certo Systems? I spent, I don't know, 9 years in hardware, robotics, the last 12 in software. But yeah, explain to me, I guess, like if I don't know, you're talking to my 11-year-old girl or something.
Yeah, no, that's a great tagline. So I'm essentially uh, building like a hardware mocking kind of idea that interacts at sort of like the operating system level. So where you create like file descriptors and stuff, and you're sending data and you're receiving data from there. I'm basically using that interaction to kind of spoof the hardware and give you the ability to create the behavior of what the data comes in and goes out as. So yeah, maybe that was a little too high.
Interesting. Yeah, no, I'm definitely interested in going deeper into all this. But I don't know, I find geeking out on the tech and the business stuff falls a bit flat if people don't know about, the person that's like building all of it. So I guess
Yeah,
tell me a little bit about yourself. I was reading, so you started out in electrical engineering, right? And
that
your
that was
first,
my. Oh,
yeah,
sorry. Go
sorry, go ahead. No, go
ahead.
ahead.
No. So yeah, so I got just my bachelor's in electrical engineering. I got the foundations, and then I went to work for a software company that did like basically a sonar application on submarines. So I used to I put the theory to the test, and everything was kind of in software though.
Interesting. By the way, sorry, this is so random and probably
Yeah.
tangential, but did you hear the Mid-Journey thing?
No, what is that?
Have you heard of Mid-Journey?
No.
Oh, okay. Uh, yeah, maybe maybe I won't go off to the tangent. But Midjourney, they're like like how AI is obviously like taking over the world right now, right? Like in every way. But like they were the first like OG image generation AI. They like literally like I think about a year or two they were king. They've kind of lost their throne now because of a lot of the other ones, but the founder of that company is super interesting guy. They've never raised any outside funding. They do some cool things, but they just like launched this thing. I don't know how to explain it. It's like an MRI system where you just like go into like this hot tub like thing.
Mhm.
They use sonar. They use essentially like sound technology to like map out
Whoa.
everything. And it's yeah, and they're saying it's like what MRI does, but without the $1,000 cost price, without the claustrophobia, without like
Whoa.
all the downsides. Anyways, so electrical engineering. So can you tell me? So what was your first, I guess, real job? What you were working as a system operator trainee. What was that
Oh
about? Like,
yeah, that's almost unrelated, but yeah, right out of school, I got a job at a power distribution place where I would then interact with the linemen. I was just a trainee, but I was working with other system operators to kind of do the maintenance on the grid, and also in like electrical storms, like if power goes out, you can reroute the power and stuff like that. So I was doing that for a little while, but realized it wasn't exactly where I wanted to go. It didn't turn out what I wanted.
yeah, I was gonna say. So what drew you to like the hardware layer?
Yeah, so when I was trying to pick which what I wanted to do, so I went to community college first and I got a general engineering degree. I was trying to just I wanted to do something in alternate energy and I wanted to like be a somewhat driving change there. And so I there was like alternate energy engineering degrees, but that was like figuring out which like solar or wind would be good here. And that wasn't really understanding the why and like how electricity is generated and all that sort of stuff. So I decided to go down electrical engineering and do had a few classes in power electronics and analog circuit design. And I kind of liked a little bit more that area. And that's kind of what drew me to the electric grid and being a system operator trainee was the power electronics and grid operations and stuff like that.
And then you went back for a master's in computer science, right? So I guess your training and your first job were both hardware. So what made you decide you needed kind of like the software half of the stack?
Yeah, so it was interesting. So even though I got my bachelor's in electrical engineering, I had got my minor in computer science, and I had shifted that specifically because I got some advice from someone that was an electrical engineer already. He worked at Qualcomm, and his advice was that like there's one electrical engineer for like 7 or 8 software engineers on his team. And so it was just kind of like his advice was, software is going to be a much already was, excuse me, already was pretty big and it will just continue to become more and more important with the software. So I kind of just continued that idea from the minor to then getting my computer science master degree.
You also spent years building inside large, defense and intelligence contractors. So what did that teach you about how, hardware and software teams really like work together and exactly kind of where they break down?
Yeah, that's kind of been a real big learning for me. Like, so my first introduction was, like I mentioned, it was like a sonar application on submarines, and they always had to get like the hardware and the operating system from the integrator. Like, so Lockheed Martin was like the integrator, and they would provide, um, their version of the operating system. It's like locked down and stuff like that. So we always had to wait on them to provide that. We had to wait on our hardware team to get the actual like new hardware because their idea was they had new hardware every 2 years and then new software offset every 2 years. Um, and so uh, there was a bit of waiting there. But during that time, what they were really good at that company, they were able to manage and upkeep their own um, simulator and stuff like that. Uh, and well, so I really learned like how distributed system works and how it integrates with everything. And they did a pretty good job, but it did take away resources from working on the actual product and things like that. Um, so that was my first introduction. We had a really good culture around like designing and um, executing the vision, and then um, from there I moved to more of like a counter unmanned aerial systems with RF technology, and it seemed a little bit more Wild West, which isn't necessarily a bad thing. But when it comes to trying to integrate the hardware and the software, a lot of times people kind of miss the mark with coming together with everything. And then even when you are maintaining like a legacy system, you're lucky if your team has one piece of hardware because a lot of these times they're like millions of dollars piece of equipment and the government has to foot the bill for it. So they're not going to give every engineer like multiple of these. You're lucky if your team has one. So that means people have to share time on it. And there's just a lot of like clash when you have government contracts, which typically require dozens of engineers. So when everyone's competing for that one piece of hardware, there's always some kind of issue and timelines get pushed back and excuse me.
So looking back, was there like a through line, like a kind of engineer you were becoming, like that made kind of starting a company feel inevitable rather than a leap?
Yeah, that's a really good question. I think one of the first things that I noticed was I was willing to, like, take on more responsibility than, necessarily was in the job description. So, a lot of times um, on government networks, you have to transfer, from low side to high side, like, any kind of technology and stuff like that. So, a lot of times I would wait like, if my tech lead was out, and they were the only ones that was able to um, perform that action. I had got the training to like do it myself, do the scans first, and then do the transfer. So there was like a like I just want to get the thing done and not just like clock in and clock out. So that was kind of my first inkling to taking on more responsibility. And then later that shifted to trying to create a process that didn't introduce so many human potential errors where they might like slip up and forget to remove their custom software on the one piece of hardware that we have, and there's relies so much on potential human error. um, so trying to advocate for that and seeming like that was a kind of against the way things were done. And so I tend to have strong opinions about when uh, I should move forward, but then being blocked by some level of management for better or for worse that led me to um, try and create my own business value.
So there's a line on your site I keep coming back to. So certainly through certainty through emulation.
Mhm.
So when did it click that you could, essentially codify what hardware does so software teams could build against it before the hardware even exists?
Yeah, I think it's sort of like it's been this long, like I didn't even know I was like building that idea um, until I tried to put it in practice, which was I was playing around with this tool, Pulse Audio, which I'm not sure if people are familiar. It's a Linux server for like audio devices, and so it held a few different um, like syncs that you could like subscribe to and like see the audio play. So I kind of got this. I kind of saw that you could view audio data that's streaming from a different application, and I could play that. um I was playing around with making like a I forget the term, but like when you have the frequencies dancing up and down based off of the bandwidth, like a spectrum analyzer almost, but for audio.
Equalizer?
Equalizer, yes, thank you. And so I was like, okay, interesting. And I had already known that like Linux obviously has like file descriptors, that's like its interface to like the actual hardware and stuff like that. And so I was like, maybe there's a way to really use that idea in a way that allows software teams, they don't have to create a new API. They just Certos systems, it'll completely interact with your application just like a debugger would. Like you wouldn't create an API to work with a debugger. Certo, Emu is the product, can work with it the same way. So I was thinking maybe you could create the hardware behavior and have it interact with the software, and that in essence is the emulation that I'm going for.
You said something I think that most people in your space would probably push back on, right? Like that hardware code cannot be done in a fully like agile process. And you're building the future where essentially it can be. So can you walk me through that? Like because it's a strong claim.
Yeah, I think there's still a whole bunch of work to be done yet, but the idea being, um, now we can kind of create the hardware behavior so that it can run in this engine, the Certo engine, and it doesn't need the UI. So at least what's working right now is that the software uh, can make requests to what I'm claiming as like the virtual hardware behavior file, and the Certo engine runs it. And like in a CI environment, you can have the what you've designed as the hardware behavior, what any customer would design as their hardware behavior, and the Certo engine kind of like would be where the hardware mock kind of sends and returns the data to the software. So software can essentially work with quote unquote real hardware behavior in a CI environment. And that's kind of what's working today. And where I see it in the future is you can then start putting, your kernel drivers into a different product, and it's all working through the virtual hardware behavior file. And then you could create, use your hardware description language files like Verilog or something as a way to like use what you're already going to put on the device as a product that the software can make the request to, and then all the registers are all mapped out in the hardware description language. So now you have a way where the hardware can make requests of the you can create software behavior in the same way, and so then you have your real hardware kind of make requests to what you kind of code as the software driver. So it's still a huge learning experience for me, but the whole idea is you can run in a shell like what you have designed in the virtual hardware behavior file.
Uh, um, Hardware in the loop. What am I missing? So, like, I mean, isn't this how they build planes and all this kind of stuff for years? Like, in the sense that you're not like obviously testing it on the actual plane, right? Like, or what's, I guess, yeah, what am I missing here?
Yeah, and to be fair, this is a lot where my learning, like I have to learn a lot more too. I've been mostly on the software side, but from what I understand, hardware in the loop, they require um, relatively bigger machines, and they're a little bit um, more expensive, but that still is specific to like the hardware team.
Mm,
I haven't known software teams to be able to interact with that hardware in the loop kind of behave, environment, I guess. And so I'm not necessarily advocating for removing that completely, but I think Certo is more going to be able to bring everyone in a product team together where your system engineer can design what the interface between the hardware and software is. Your hardware team can kind of define what the hardware behavior looks like, and then the software team can interact and write their features and fixes against that. Um, and so that and that's when you actually like the hardware in the loop kind of idea is when you do have the hardware. This is almost before you have it, you can kind of flush out the integration between the software and the hardware before you are working specifically just with the hardware.
interesting. Plenty of engineers feel that pain and they just kind of live with it, right? So, what made you the one who like walked away from a stable defense career to go fix it?
Yeah, that's another great question. I was becoming very, very frustrated with the way things were. I didn't find that my work was to the quality that I felt it could be, and that was because of this lack of the ability to test and really verify my own changes. Um, there was a lot like we had tests that were against simulators, but the simulators were always out of date and stuff like that. But I could never get the okay to work on those simulators to make them better. And so then not only did my work suffer, but all my peers' work suffered, and and everything like that. And I felt it became very apparent that I was fighting kind of just like the business, like the way things were, and kind of understandably so. Like the government's the one that's paying for what we do, and so they wanted more. They wanted to pay for features and bug fixes that were immediately important, um, at the expense of us not being able to uh, create like a long-term kind of simulator every time new hardware was made. So I felt like if I could do something on my own, relatively cheap, that other teams could use and work with, and then I could really make a difference. I could get the need for feeling like the work that I do is up to my own standards, and I can make a difference in the process.
Like when founders almost always find their first idea was a little wrong. Like once they actually started building it. So what have like kind of like the beta and your early founding partners taught you that you couldn't see when this was just like a, I don't know, like a frustration in your head?
That's a good question. I don't know if I've even gotten to the learning point yet,
Hmm.
um, at this point, and that's where we're really kind of at this point is, I've built something, and we're really looking for people to shape it, in a way that makes sense for the actual end user. I've got something out, and I'm looking to mold it based off of what the feedback is.
So can you give it to me straight, like the way you would kind of explain it to an engineer at a hardware company? Like what is Certo? What does it let their team do kind of like on day one and like what can they not do as well?
Hmm. So I would say they can start building out the interface. So there's the ability right now. Um, you can import your schemas. So a lot of times, hardware, uh, you build whatever your communication is, your structs and all that sort of stuff that uh, packs the data however you want it to be packed. It works, and so you can import directly from your header file that you already have. So it'll like build out all the structs, whether they're um, meant to be sent to the hardware, or it's something the hardware responds with, or if it's a both way. Um, you can get the ioctal codes, or whatever. You basically import what you've already done, based off of the code. There's that We don't have support for like Excel sheets or PDFs just yet, um, but using the actual code, you can import all that. You can import from standard ideas like Bluetooth and stuff like that. There's already these operating system header files that it comes with. You import standard stuff, libUSB. Um, there's support for that, and so that's the first thing. You would import what the data looks like, um, and furthermore, I just made this new feature where you can import from a template. So you don't necessarily have to build the system calls out. So you can um, just import like the USB template. So that comes with all the system calls that are meant with the standard USB. It comes with the structs and all the arguments that go along with each system call. So that's like the first thing. That's where you start codifying the hardware interaction. So instead of you have Confluence pages of what things do and how they work, and then pretty soon they get out of date every time you get a new revision and new engineers come on board. Old engineers leave, they retire and they take their experience with them. This is where you can bake in um, the behavior and some documentation with each system call. So like there's even like I have like a markdown text input per system call where you can put um, you know excuse me, where you can put the where you can put like any like description or cautionary like information there, like that basically transfers down the knowledge base to any engineer that wants to use it. Um, so I have that uh, ready. And then from there, you can say per system call what each system call will, what the behavior of each one is. So, like if you want to open a device, you do the open system call, and then you can write a TCL script, which like sets some variable. And the reason why I use TCL, which I may have to change in the future, depending on if anyone prefers something different, but TCL is a tooling command line, which was one of the original uh, languages to describe hardware and scripting for hardware. So I felt it was a good natural way to reach driver and firmware engineers. But you can define like global variables. So if you want to define like a register or something, and open like sets that register to 0, you can basically mock that in the TCL software. And so um, you would open, and then any ioctal call that like sets a center frequency or sets some value, that register, you can basically say that that changed. Um, and then, maybe a read system call, you would just read what that variable is and use the TCL scripting language. It'll has like a global registry that can read your global variable. Um, so you don't have to, so it's not just tied per system call. And then there's an emulate page, which is more for the software engineers, where they can turn on and off an emulation. Excuse me. You can specify, per pure virtual hardware mode. And so that's like if your hardware isn't even plugged in, it will spoof the file descriptors so that um, each engineer at their own desk can work with the hardware behavior without actually needing the actual hardware there. You can create manual overrides, so you can basically make sure a system call fails. You can specify what data you want the return to have. So if it's a struct, you can specify which override values you want returned to your application. And then you can turn on just the TCL logic so that it basically blocks what the operating system is going to return, and it returns whatever the TCL logic returns. And so, I forgot to mention, in the TCL logic, you can specify, like you can intake the data, convert it to any struct that you have made that you already imported from step 1. So you could say like, take argument 3 and convert it to a Bluetooth send struct or whatever. And then you can manipulate the data just by like a TCL dictionary rather than working in zeros and ones. So anyway, you can manipulate all that in the emulate tab. And later on, we don't have this yet, but we're going to allow users to provide their raw playback files. So oftentimes, a lot of times companies and engineers, they already have like raw data that has like a signal or something that has some information that they want to make work with their software. So they want to handle this spike or something. You could use that raw playback as the driving of the data, so that your software engineers can use the real hardware behavior, but it can use this like playback file to provide the actual data. And then there's lastly an observe tab, which allows you to inspect the system calls, what the result was, how much time it took, and what the actual payload was, just to make sure that your system's healthy. And so that's essentially what we have today. And where we want to go in the future is, what I really want to do is to be able to take the history data that comes in and be able to export it and play back against that same hardware behavior. So now you can record true timing of what happened when a QA engineer fails a test, and then they can send the that data to uh, the engineer who's responsible for making that fix or whatever. And so now you don't necessarily need to be on the actual hardware to see the timing and the behavior. You can just replay um, what was observed on anyone's own machine. So that's essentially the environment, and the also next step is like taking it to the cloud. So if you want to figure out how your application can handle multiple, let's say drones or something like that, it's almost impossible to have 20 flying around, in real life. So if you wanted to, you can make multiple instances using just the VHB file, and using the Certo engine to provide that behavior to whatever software is driving the communication. And so then pretty soon you can create multiple instances of the hardware that you want to interact with, um, by creating them in the cloud. So that's essentially where we want to be um, soon.
And your first wedge is RF and software defined radio, right? This
Yeah.
legacy custom hardware where the pain is probably the sharpest. So I guess why start there, and where does the emulator go from there?
Yeah, I think I'm starting there mostly just because that's what I know. I
Got
felt
it.
like that's where my pain point was, and um, I could talk a little bit more intelligently, not too much, but a bit intelligently about it. And I think where we go from there is, um, I'm not entirely sure. I think I'm hoping to get some customer feedback on where it can go, but um, honestly, just work on any kind of hardware that's meant to interact with um, software, and because it's essentially the same technology that can handle. It's really just a communication protocol, and it's raw bytes that come over the file descriptors. So
Cool.
really, I've given. Oh, go ahead.
And Peter, what does GTM look like? Like, how do you go to market? Have you thought through that, or are you still kind of
Yeah, my my business partner is a bit more versed in that, but right now we're just reaching out to where I've worked before, seeing if there's any interest. We've we've got uh, some mechanism we're using like Reddit and Facebook groups, and we're trying to get
Mhm.
ChatGPT like the SEO kind of optimization. So um, our first real task is getting beta testers sign up so that we can get some initial uh, you know feedback, and they get 6 months free, and then after that, 50% off for the lifetime of their usage of Certo. So
Cool. Interesting. Cool. Well, help me land this one, I guess. So I don't know, play it forward maybe 5 years. If Certo works the way you want, how does the way hardware products get built look different?
mm,
And what does that unlock for the people, building the next generation of machines?
yeah, yeah. So I think in 5 years, hopefully, we have the ability to incorporate like hardware engineers into like a real CI/CD into that chain, and um, they can create the hardware behavior in the first sprint. Software engineers can take that hardware behavior, implement their own, um, whatever feature that correlates with that. The QA engineers can then test what the first two engineers made. Any issues, then get put into a bug beforehand, and so now you're catching things in weeks rather than months later down the line. So that's the first thing, and we also have we're also working because AI is such a huge deal. Um, One of the things we hope to do is incorporate an MCP server associated with it, so you can essentially associate the hardware behavior and anything that is coming over, like any data that's happening, yeah, it can be put into an MCP server, so an LLM could just query, like you could query it.
That's so cool.
Yeah. Yeah.
Yeah,
Yeah,
that's
so
definitely the future.
yeah. So if your software is meant to deal with multiple pieces of hardware, how do you even test that? And how do you have an LLM be like, I want to make sure that there's nothing happening over here. What's the bandwidth at this state? Like how can you have something coordinate with multiple pieces of hardware and being able to test that without multiple pieces of hardware? It's already hard enough with one piece of hardware. And so having the ability to distribute
Peter, do you think, like, you know how software has become like effortless and like almost
that.
delightful, and like literally anybody who has even just like the tiniest bit of courage can build something, right?
Mhm.
Do you think hardware will be that way in someday? Like, do you think we'll, like, I don't know, I got a 3D printer back here, but it's mostly collecting dust just because like I'm not gonna go to Thingiverse and download someone else's thing. But if I could just like, will it into existence, like
Yeah.
create a toy car for my 2-year-old, and boom, it just like whips up something super cool like a Batmobile or something from the future. Like, do you think it's gonna eventually go there just with LLMs finding their way to hardware? Or like
Potentially,
or I guess AI finding its way to hardware?
I think so. I think they're definitely it could definitely design it, and you could really
Mm,
conceptualize it. What you said about 3D printers, like, I think if you can get PCB etching to be done, like, as a 3D printer does, then, it could exist in your home, then very, very well possible. Or the 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 hard stuff, or, like, the
yeah, it's like,
intermediate point would be it could send the plans to, a PCB etcher, and they can create it and then send it to you. But you'd be more sure that what you wanted worked because of, what I feel we're making.
awesome. Well, what an exciting future. I'm gonna bring this stream to an end. Anything else you want to share, Peter? Where do you, like, are you on LinkedIn? If people want to double click on this whole like idea, this opportunity, where do they find you and your company?
Yeah. Yeah, I mean, first, I invite anyone interested in something like this to, the Certos Systems. You can find the beta sign up page if you wanna, give it a shot, or you can follow me on LinkedIn. You can find me, Peter Brady, or we have a Certos Systems page. We have a YouTube page, at Certos Systems, and same thing with Instagram, at Certos Systems.
Okay, awesome. All right. Well, thank you all for tuning in, and yeah, until next time. Peter, just hang back for 2 minutes. I'm gonna bring this one to an end.